Alright, this is problem number 4 for the 5 problems of extra credit, and it's a problem from a past ACX exam, and it reads as follows. Consider this reaction, and it gives us copper ion plus iron solid yields copper solid plus iron ion. And then it gives us that its standard EMF is 0.78 volts. Then it asks, what is the value of the non-standard EMF when the concentration of the cobalt ion is equal to 0.040 moles and the concentration of the iron ion is equal to 0.40 moles? And then it gives us the following answer choices. A, and it looks a bit weird, but bear with me as I'm trying to deal with some technical difficulties here. Alright, so since they give us the concentration for our copper ion, I don't know if I've been calling it cobalt, but it's copper. Hopefully I haven't been. But our concentration for copper ion and our concentration for iron ion, and this basically tells us just out of straight up the fact that they're not in standard concentration, which is 1 molality, or yeah. It basically tells us that we're going to be using the Nernst equation, which is E non-standard is equal to E standard minus 0.0592 over N times the log of Q. And this is the same as the other equation we used in previous problems, where instead we used, I believe it was just 0.0297 or 57, something like that. And instead of using the log, we used the ln. It's basically the exact same thing. It's actually the exact same thing, except here we're using the log instead of the natural log. And yes. Anyway. And now what we do, since they basically given us everything for our equation, what we have to do in order to solve for our non-standard EMF is basically just plug everything into the Nernst equation. And all we have to do is our standard EMF, which they give us to be 0.78 volts, minus our 0.0592 standard or constant over the moles of electrons being transferred, which here is 2, times the log of Q, and the log of Q is basically Q is basically equal to K, our rate, our constant, equilibrium constant. It's just when it's non-standard. So basically when with the concentrations that they've given us here, it's just going to be the concentration of our products over the concentration of our reactants. And remember that we don't include solids into said equation because the concentration of our solids isn't really going to affect our overall reaction. So it's going to end up being the concentration of iron ion, which is 0.40 moles, over the concentration of the copper ion, which is 0.040 moles. And we plugged everything in, and all we have to do is plug it into our calculator and solve for our non-standard EMF. Alright, so after I plugged everything into my calculator, I started solving for the 0.40 molality over the 0.040 concentration of the copper. I got 10, the log of 10, then the log of 10 is equal to 1. So over here, I just divided the 0.059 by 2, and I got 0.0296. And then I subtracted that from the 0.78 volts, and we ended up with a non-standard EMF of 0.7504 volts, or about 0.75 volts. and that matches with B, our answer here, and that's our answer B. Thank you.